3. Get excited.
Yay!
We're going to look at the graphs of quadratic functions. We're going to talk about how the equations are transforming the graphs. This is going to call on stuff that you learned at some point in Algebra 1, but then more in depth in Algebra 2. Look at stuff you covered in Algebra 2, and hopefully if you did not understand it in Algebra 2, you'll understand it better with me, and then we're going to take it to the college level. So let's dive right in. We are talking about just quadratics in this section, so that is a nice little break from the higher degree polynomials. This slide right here is reminding you of what's called vertex form for quadratics. That would be f of x equals a parentheses x minus h close parentheses squared plus k. You will notice this is supposed to be an asterisk, although it looks a little messed up. But that asterisk right there is designed to remind you of where there is a sign change. So I've put the little legend up here, or the key, to let you know that the asterisk stands for when there is a sign change. We've talked about how any variable that follows a subtraction sign has a sign change, and that is what happens with the h. When a quadratic is in vertex form, you can see the vertex. The vertex is the coordinate point of the numbers in the positions of h and k. So the vertex is whatever the number is for h and whatever the number is for k. It's really important that you understand that vertex form shows you the vertex and you can read it plain as day. Just do a sign change on the h. Coming right here to these examples, let's box this one in. This one is the mother function, y equals x squared. That is the basic parabola that has had nothing done to it. This should ring a bell from our last chapter, or the last chapter. This is the mother function, and what's been done to it? 2 in the front does what?
Stretch.
Vertical stretch. Remember the rubber band example? Lots of energy to stretch a quadratic. So that is a vertical stretch by a factor of 2. Look at this one right here. Vertical stretch by a factor of 2, and then which way is it shifting?
Left.
It is shifting left, how many?
3.
3. Look at the last one. Vertical stretch by a factor of 2, shifting left 3, and also going
down 5.
Down 5.
Come on.
If you struggled with that, and some of you did get that wrong on the exam, which I'm almost finished grading, I just have a few more left. If you did get that wrong, we need to make sure you master it because it's coming up again in here with quadratics. Go to the next slide. Now, there's a lot to write here. Before you just start writing it down blindly, let me explain some stuff to you. First of all, there's 2 graphs here. Don't write anything yet. You've got 2 graphs. There's only 2 scenarios for a quadratic function. It's either going to open up or it's going to open down. So both scenarios are shown here. When it opens up, it's because the leading coefficient was positive. If it opens down, it's because the leading coefficient is negative. Leading coefficient meaning a. So a is greater than 0 or positive. Here, a is less than 0. Notice both scenarios, a specific point is right in the middle, whether it's opening up or it's opening down, and that point is called the vertex. The vertex splits the quadratic. It is the middle, and it is also the extremely highest point or the extremely lowest point, depending on which way it's opening, right? See the dotted line going down the middle? The blue dotted line on mine? Both of them? That dotted line is called the axis of symmetry, meaning it's where you could take the quadratic and fold it, hot dog style, and the graph would match. The axis of symmetry, looking at the picture, always passes through what? The vertex, because the vertex is in the middle, right? So, over here to the right is giving you a summary of all the properties of a quadratic. You have, if it's opening up, A is positive. If it's opening down, A is negative. The vertex is the numbers in the place of H and K, sign change on H. The vertex that the axis of symmetry passes through, the equation, EQ stands for equation, is X equals H. Then K at the very end is what determines, the min or the max, depending on which way it's opening. I'm going to let you write all of that down, and then I'm going to continue explaining, and then we'll put it into practice. So write all of this down. So everything up here is stuff that you're already familiar with, probably except for the axis of symmetry, which is why I highlighted it in green. If I say, what is the equation of the axis of symmetry, you would direct your attention to the vertex, and because the axis of symmetry will always be vertical, it is a Hoy-Vux scenario. Well, vertical means it's Vux. How do you write the equation of a vertical line? It's X equals a number. How do I know the number? Well, if it's passing through the vertex, it's going to be X equals whatever the X coordinate is of the vertex, which, because it's in vertex form, is always H. Does that make sense? So there's a lot to connect there. Axis of symmetry is vertical. Writing the equation of a vertical line is X equals a number. Because it's going through the vertex, it would be X equals the X value of the vertex, which is always H, because of vertex form. So, X equals H is the equation for the axis of symmetry. I highlighted the X in the word vertex and underlined it like 3-4 times because I wanted you to equate, like a weird way to remember, the vertex. It's going to be X equals the X coordinate of the vertex. You see how I'm looping that all back around? So hopefully that's going to help you remember what to look at. The X value is the equation of the axis of symmetry. Look how many times the letter X appears in that. So that's how you know it's the, or that's a corny way to remember that it's the X coordinate of the vertex and it's X equals that number. Now, go to the next slide. I'm going to leave that there because I think you're going to end up looking back at it and answer those two questions. I gave you a chart. I'm asking you to fill it in. Tell me what's the vertex, what's the axis of symmetry equation, is there a min or a max, and if so, where is it? Thanks. So if you need to look up here, you can. What number, or not number, what letter from vertex form tells me which direction it opens? A. A determines if it opens up or down. That's going to answer your question of whether it has a max or a min. You got to know which way it's opening to say if it has a max or a min. Can it have both? No, cannot have both. looking at the first one, A is what? A is 3, which means it's positive, so it's opening what direction? Up, which means it has a min, which means it has, in terms of a max, none. Right? There's no max. The letters H and K tell me the vertex of the quadratic. H gets a sign change. So the vertex is
1/4.
1/4, -2. The axis of symmetry is x equals
1/4.
h from the vertex. X equals 1/4. That is the equation of the line that will pass vertically through the quadratic. And it has a minimum. The way that my math lab has you answer this, we've talked about it before, is they always make you say the minimum is at y, like what number, and then it'll say at x equals what. So you're kind of reading the point backwards. What part of the quadratic did we say is always the max for the min? The
Vertex.
vertex. So go back to your vertex point. So the minimum is the y coordinate, let's say, is -2 at x equals 1/4. That's a check mark right here, by the way. That was me just saying, yes, it has a min. Yes, you can write the actual point itself. However, on my math lab, they're not going to ask it in that format. They're going to ask you to say the y value first, and then at x equals whatever number. Have y'all had plenty of time to try the next one? Okay, what's y, or not y, what's A here?
-3.
Okay, so it's opening down, which means it has
The max.
a max, but that means no min. And then we have H, K, don't forget, sign change on H. So what's the vertex? What's the axis of symmetry equation?
X equals -5.
Tell me the max.
7 at -5.
What do you think?
Seems easy with light work. No way.
Okay, well, what if I did not give it to you in vertex form? What if I said, here's a quadratic, tell me the vertex, the axis of symmetry, if it has a max or a min, and then graph it?
Yep. Calculator.
Well, you definitely need the calculator for the graphing part, right? What format is that quadratic in? Do you remember what it's called? I heard it. Standard. This is called standard form. Now, there's two ways to finish this problem. There's think smarter, not harder, right? Ironically, the harder route would be completing the square. You would complete the square here because we need it in vertex form, right? We need vertex form. I can't read anything about this quadratic when it's in standard form. I can tell you if it opens up or down, because A is the same, but I can't tell you what the vertex is, which means I can't tell you the axis of symmetry. I can just tell you, oh, that one opens up. To get vertex form, technically, you're supposed to complete the square, okay? But there is a smarter way, and it's not cheating. It works every time. I would definitely say it's more intuitive than doing completing the square way. It'd be like if you had your choice between a free car and you wanted manual or automatic, and it's going to get paid for, you're going to probably pick the automatic because then you can get on the interstate without having to worry about shifting gears, right? Traffic, shifting gears. Y'all know what a manual is? Okay, good. I didn't know if we're already to that point where kids don't know what manual cars are. We're not talking. We're not talking Fred Flintstone, you know, where you pedal with your feet. But so let's do this. Let's do completing the square to just have you practice that because it was from the last section. But then I'm going to show you the smarter route, which would take way less time, give you the same answer. It's not a shortcut. It's a more intuitive way to do it. All right, so if we are going to complete the square, we're going to do that over here in this big space. You will notice I do have this blocked off because this is where I'm going to do the smarter method, okay? So if you want to organize your work that way, you can. So in completing the square, we've got our x squared plus 10x, right? And then we need something here. We've got plus 23. The 23 would technically move to the other side. Now this one's a little different than the one yesterday. The one yesterday, we moved 23 to the other side, and whatever we did to one side, we did to the other. Well, this is a function. I don't want to necessarily subtract 23 over here because I've got an f of x. I don't have a 0, you know what I mean? So watch what I'm going to do. I'm going to draw another line. One of them, I'll save that question for in a second. All right, we're ready to do the shortcut. Do you remember it?
No.
What are the shortcuts? X plus b over 2 squared, right? And then that's what took the place of this. Then we've got plus 23, and then we have this line, right? Yesterday, whatever we did to one side, we did to the other. But now I'm on the same side. So how can I keep it balanced? If I add the same thing, then I've just added it twice. So how would I change it? Like if I add 4 here, now what you're adding right here is 25. This is add 25, right? 10 over 2 is 5.
So you take away
is
25.
what?
You take away 25.
So take away. So the difference is right here you would have to do a minus and then b over 2 squared because you're on the same side. Now, if this is throwing you for a loop, let it go in one ear and out the other because I'm fixing to show you the smarter way. You know what I mean? All right, let's clean this up. This is ugly. So this is x plus 5 squared. That's plus 23 minus, we said this is 25, so it'd be minus 2, right? So, what is the vertex? What is the axis of symmetry equation? What? X equals -5. Is it opening up or down? So it has a max or min. It's opening up, it's bottoming out. So it has a min of what? -2 at now. While that was not at all like exhausting, let me show you a technique that you're going to like. Let's see, where does it come into play? It comes into play in 2 slides, but I'm going to show it to you early. Okay, so you can go ahead and see it in practice. There is a pattern when you're dealing with a quadratic and you're going to like solve for x. There's a pattern when the quadratic's in standard form. This is A, this is B, this is C, and ax squared plus bx plus c, like A is always in front of the x squared, B is always in front of the x, C is always the constant with no variable at all. Or you can take the quadratic in standard form and just find the vertex by hand. Instead of getting it in vertex form to state the vertex, we can jump straight to finding the vertex using this formula. X equals negative b over 2a. Negative b over 2a. If you will take a and b from quadratic in standard form, plug it in, you will get the x coordinate of the vertex. Now, how do you think you get the y coordinate? Plug it in. You just plug it back in. So, make a note, and plug x in to get y. Now, I say x and I say y, but really it's h and k, right? Or h and k, okay. Just want to make sure you understand that. We are talking about the vertex. So here we go. The x coordinate will be negative, what's b? 10. Divided by 2, what's a? 1. What's negative 10 divided by 2? Negative 5. Now plug negative 5 in. Plug it back in right here. Negative 5. You do need to put parentheses around the negative, by the way. Because negative 5 squared is positive 25, so be careful there. You get negative 2?
Yep.
You should have, right? We just did this problem, right? So then you could answer all of the questions that we've already written over here. There's no need to write them twice. But so the vertex is, what is it, negative 5, negative 2. I would be able to answer all of these questions because that would give me the vertex, which then gives me the axis of symmetry equation, which then tells me if it's where the max or min is. I would have to look at A to know that, right? I need to look at A to see if it opens up or down. Now it says to graph it. We've run out of room, but if you were to, let's see, it's left 5, down 2, opening up. So left 5, down 2. So it's something like that, right? I mean, that is a sketch. Okay, go to the next one. College level, what's different? There's a fraction. I know. But, now you can see why I went ahead and showed you the more intuitive route, because it works every time. In years past, I've made the students complete the square with that next quadratic. And let's just say it's exhausting what you have to do. We are going to go ahead and use the intuitive route because it's the one that's more practical and that I expect you to continue to use. All right, it's hard to see this quadratic the way it's written, so I'm going to rewrite it right here underneath. That's a 1/2 x squared minus 4x plus 8. Now I can see A is 1/2 and B is negative 4. We're going to use the intuitive way to find the vertex. First, find the x-coordinate. Negative b over 2a is the formula you're going to have to memorize. You're going to have to know when to use that, okay? Negative b over 2a. All right, let's plug it in. So that's negative 4. No, excuse me. Negative b. So negative b, right? Over 2 times a. So on top I get what? Positive 4, and on bottom I get, please get it, 1.
So it's just 4.
Multiply the fractions straight across. This 2 right here is understood to be over a 1. So that's 2 over 2, which is 1. So the x-coordinate of the vertex, or h, is 4. Now, oh, it's a g. Find g of 4. Go plug it in. When I go to the calculator to type that in, I would probably type the 1/2 as a decimal, so then I don't have to worry about like accidentally, you know, being in the wrong spot.
Just hoping, can we get a break after this slide?
There's only 3 left.
After this slide.
What'd you get when you plugged 4 in? Did you get 0? So, let's come over here. It said find the vertex, find the axis of symmetry equation, state whether it has a max or a min. Okay, we'll do that in a second. All right, what's the vertex? Isn't that so much easier? Like, I just want you to appreciate as I walk around. Please take note of my work where I completed the square. Because of the 1/2, I had to multiply a 2 in the front. Because remember, completing the square, you have to have a what in front? A 1. I don't have a 1. So I had to multiply the whole function by 2, then complete the square, then go back and take the 2 out. Are y'all paying attention? Thanks, Ms. Holcombe, for letting us take the intuitive way.
Thank you so much, Ms. Holcombe.
Thanks, Ms. Holcombe, for letting us take the intuitive way.
Bro wants extra credit.
All right. What's the equation of the axis of symmetry? Once you know the vertex, remember x, like it's literally feeding you the answer. It's x equals 4. Go back to a. Since a is ugly, but it's positive, then it's opening up, right? Because a was 1/2, so it has a min of, now back to the vertex, 0 at x equals 4. Please go to the next slide.
Miss Holcombe, tell him. Say pause. Look at Pierce and say pause.
Go to the next slide. So I have good news and bad news. The bad news is we have a little bit of writing to do here, but the good news is I've already taught you this. I just taught it to you 2 slides ago to save you from the headache of completing a square. This box is showing you the formula that I've already presented to you, which is negative b over 2a. Now, it looks a little different. Let me explain the formatting here. You will notice you have a big set of parentheses. This represents a coordinate point. You will notice in the position of x is negative b over 2a. Notice they put the negative in front of the fraction. I always write it with the b at the top of the fraction. Doesn't matter though. We've already learned this. The x-coordinate is negative b over 2a. Notice instead of writing the letter y, they have written f of negative b over 2a. Well, if you go back to the ones we just did, second step was always the function of the x value we found, right? So this is just writing the format would be formulas in position of x, and then in terms of f of x for the y coordinate. You don't have to memorize that necessarily. What do you have to memorize? You need to memorize the x coordinates negative b over 2a. We've already written that down. You need to memorize that you plug x in to get y. Now, let's practice. So you should already be able to do this. There is one additional question on here. No, two. Two additional questions on here. Calling on stuff from the last chapter. What is the range? What is the intervals of increasing and decreasing? So I'm hoping that if you still struggle with that, here's another opportunity to try to master it. Please answer this question right now. Find the vertex. Tell me if it has a max or a min and where. Sketch it. Y'all saw what my sketch looked like earlier. I'm not looking for anything perfect, just a sketch. Can you read the range? And can you tell me the intervals of increasing and decreasing? And go. At least you can hear it.
Can we pay attention to class, please?
You want to say that.
So, what is A?
7, 2.
A.
Negative 1, sorry.
Negative 1. What's B? 14.
Right there.
Okay, so negative B, recording over 2A. So negative 14 divided by negative 2 would be positive 7, right? Yeah. Then I'm going to find f of 7. I had a great question. It's where does the negative go? Because the equation is negative x squared. Then it would be negative 7 squared, and 7 is what's getting squared, so it becomes negative 49. Instead of it being negative 7 quantity, like times negative 7. When you go to plug it in, here's what it would look like. Should be a 4.
I don't know.
Did you get 2? Or some more confirmation?
Yes, ma'am. The answer was 2.
All right. So the vertex is what? 7, 2. Question B says, does it have a max or a min? Well, you got to look at A to answer that. A is what? Negative, so it's opening down, so it has a max of the y value at x equals 7. Now, these last two parts, lock in. Sketch the graph before you try to answer them. You cannot answer them necessarily with just this information. You need a picture. So let's see. The vertex is right 7 up 2, and it's opening down. So I'm going to kind of do this. So right 7 up 2. And it's opening down. Now I'm going to label my infinities. To the right's positive, up's positive, left's negative, down's negative. Remember, range is the y values. Turn your head sideways. Always go least to greatest, so bottom to top. So it is definitely coming from this direction, and it stops at 2. It stops right here at 2. So the range, negative infinity up to 2 with a bracket because it is touching that number. Intervals of increasing and decreasing. I'm going to do purple for increase, Orange for decrease. Imagine a runner running the graph. They would be increasing, that was not a highlighter. They would be increasing till they get the vertex. Then they would do what? Decrease. Now I'm going to write that using interval notation. So it was increasing from negative infinity up to 7. Remember, it's always parentheses on intervals of increasing and decreasing. You can't be doing both in the same spot. And then it is decreasing from 7 to infinity.